Right, so welcome back students to one more session of your structure of atom. So yesterday's video we have done numericals, isn't it? I have done numericals based on de Broglie's equation, uncertainty principle, photoelectric effect. Now there's further numericals based on the structure of atom. I think with this particular thing I'll be finishing off all the numericals of the chapter. Any doubt in any part of the numerical, please let me know. Fine. So next important thing, I'm left with one topic, that is Schrodinger wave equation. So I'll be doing Schrodinger wave equation, and I'll be teaching you the important concept of the chapter, that is radial nodes and angular nodes. Probability of finding an electron. Where do you find the electron? Nodal plane, is it there or not? I will be seeing the concept, and with that I'll be finishing the chapter. Fine. So please do send your request or do send your comments of which chapter do you want me to teach the next. Some students have been asking me thermodynamics, some are asking me hydrocarbons, like that, different. Let me see, whichever has a majority of requests, that would be dealt next. Fine. So let us see this numerical. What do they give us here? A photon of wavelength 4 into 10 raised power of minus 7 meter. Okay, first of all, when such numerical is given, as I say, please try to write the given data. So I am writing the given data here. So in this given data, lambda is equal to 4 into 10 raised power of minus 7 meter. It strikes on a metal surface, so that is nothing but your photoelectric effect concept, isn't it? Okay, so after striking the metal surface, the work function of the metal beam. So what is work function? Basically, when I have to take a metal piece like this is the incident light which is falling on this metal piece. This incident light is equal to E is equal to h nu, energy of the photon with which it is striking the metal piece. Then this particular metal, every metal has a characteristic work functions. So I have already done this photoelectric effect where I have given you the different values of different metals. So the work function, it's denoted by W naught, or it is denoted by H nu naught. Okay, now after this strikes, whichever has, when you are supplying energy more than the work function, only the electron will eject out. So if you are supplying energy more than this, or h nu more than this, the electron ejects out. This has a kinetic energy of half is equal to half mv square. Done. Now here they have given us this value, W naught or H nu naught. This is your work function. This part they have given me. So let me erase this and start note that thing. W naught, or it can be written as H nu naught, which is equal to 2.13 electron volts. Now what should I calculate? I have to calculate the energy of the photon. Okay, I need to calculate E is equal to H nu, isn't it? So let us solve the first one. So when I have to solve the first one, E is equal to H nu. I have in this case lambda. That means the formula which I have to use is E is equal to Hc by lambda. Done. Now substitute the values. E is equal to H Planck's constant, as we did yesterday, 6.626 into 10 raised power of minus 34 joules second. Now velocity of light 3 into 10 raised power of 8 meters per second, divided by your lambda given to us is already in meters, nothing to convert. So 4 into 10 raised power of minus 7 meter. So when I solve this, I get cancel all these things and everything. I get energy value equal to almost how much? Because this second also gets cancelled. I get an energy value equal to 4.969 into 10 raised power 10 joules. This is your value. But what do they give me? They've given me energy of a photon in electron volts. That is important. So whenever you want a particular energy in electron volts, what do? You take that and divide by the charge of an electron. When you divide by charge of an electron, the ratio of the energy and charge of the electron both get cancelled. You get the answer in electron volts. So here this is joule, that is 4.969 into 10 raised power of 10 joules. Okay, divided by what is a charge of one electron? That is equal to, it is already given here, see here. So EV, I can write this as EV. It is equal to 1.6020 into 10 raised power of minus 19 joules. Okay, let us do one thing. This also joules, this also joules. So when I cancel this particular thing, I get an answer of 3.10. Now what happened? 1 electron volt is equal to 1.6020 into 10 raised power of minus 19 joules. So this whole thing, when I cancel, I get an answer that 1 joule is equal to, what is that? That joule is equal to 1.1 electron volt. So I can write the answer as EV. So this is your answer. So the first one I have got, first I've substituted the formula, then I got energy, then they asked me to calculate in electron volt, but I know 1 electron volt is so much. So to cancel that, I have taken the ratio, I divided both, then I got the answer in electron volt. So the first thing is over. How much do you get? 3.0 electron volts. Okay, now what is this 3.10 electron volts? Basically it is nothing but your energy. Which energy? Whether it is h nu or whether it is h nu naught, that you have to remember. So this is your E is equal to h nu value, isn't it? I've got h nu value. Now let us come back and do the next one. They've asked me to find kinetic energy of emission. Right, so we have got the first one. This is your h nu. So second bit, what should I do? I need to find the kinetic energy. According to photoelectric effect, what is the formula basically when I have to write? According to photoelectric effect, E is equal to h nu. That h nu is always equal to your kinetic energy plus the other, this is h nu naught. This is what we have studied already. So now I want this kinetic energy, get this kinetic energy this side. So what do I get? I get h nu minus h nu naught. How much is h nu value which we got in the earlier sum? It is 3.10 electron volts. What is h nu naught? Work function which is given to me, that is 2.13 electron volts. So what answer? Simple subtraction. When I subtract, I get an answer of 0.97 electron volts. So the second answer which I got, kinetic energy, is how much? 0.97 electron volts. This is also over. Let's come back and do the next one. Now let's come back and do the third one. What did they ask me? Ask us rather the velocity of the photoelectron. They've asked me. So velocity. So the same thing, isn't it? Kinetic energy is equal to half mv square. We have the velocity here. Let us write. First of all, let us substitute 1 value. Half will be like that only. Mass of the electron is 9.1 into 10 raised power of minus 31 kg. V square I need to find out. Kinetic energy I've already got, that is 0.97. Okay, 97 electron volt. But what is 1 electron volt equal to? Already the value is given to me. So multiply that. It is equal to 1.602 into 10 raised power of minus 19 joules. Why did I do this? Because this is in kg, this is in joule. I need to equalize the units, isn't it? So I have taken that. Now take out this V square outside and divide. What do you get? 0.97 into 1.6020 into 10 raised power of minus 19 joules divided by this whole quantity, 9.1 into 10 raised power of minus 31, okay, kg. Okay, that particular thing. When you divide, you get an answer of, this is the answer which you get. What is that? You get an answer of 0.341 into 10 raised power of 12. I still have to find out V value, isn't it? So V square, I've got that one. So V is equal to 0.341 into 10 raised power of 12 meter per second, that is whole square. When I take the square root, V value I get equal to 0.584 into 10 raised power of 6 meters per second. Still I can write, okay, still I can write it in meters per second. I've still not got, so what do? I should not write this here. Further, if I have to write this in meters per second, I'm going to shift the decimal here. This becomes 5.84 into 10 raised power of 5 meters per second. So this is your V value. So let me underline. How much did I get? V value as 5.84 into 10 raised power of 5 meters per second. So what do we do? Basically, energy, I use the formula is equal to h nu, right? Then for kinetic energy, I've used the h nu minus h nu naught value. Then for the third one, velocity, I directly took the kinetic energy formula and start substituting. Mass of the electron is given here. V square is there only. And next I've got this V out and finally got the answer. I took the square root and found the answer in meters per second. Right, so let's come back and do one more NCERT numerical. Right, what did they give us? Here, let me write given data heading. Now they've given me a 25 watt bulb emits monochromatic yellow light of wavelength is so much. Okay, first of all, write the given data. Lambda is given to me 0.57 mu micron. Here they've given one information. 1 mu micron is equal to 10 raised to the minus 6 meters. So immediately as soon as you get, because you should have all in the same units, multiply with 10 raised to the minus 6 meters and keep it like that. Now they've given 25 watt emits and monochromatic yellow light of 25 watts is given to me. H nu in that, this particular value is given. How much is that? It is equal to energy equal to 25 watt. What is 1 watt equal to? 1, it is given as 1 watt is equal to 1 joule second inverse. Nothing to do with this, joule second inverse. Fine, so simple. Now I need to calculate the rate of emission per quanta. So what actually is this? First important thing, find the rate of emission. We have two parts in this. First we need to find the energy, then go back to find the rate of emission. So E is equal to H nu. Fine, so H is again written as nu is written by C by lambda. So now introduce this. E is equal to 6.62. okay, this is what we've not written the unit. This is the total energy. Okay, 6.626 into 10 raised to the minus 34, velocity of light, 3 into 10 raised to the 8 meters per second. Lambda value, because this is in meters, this also should be in meters, isn't it? So it is 0.57 into 10 raised to the minus 6 meters. Now all are in meters. This is also joule second. So when I cancel all these, I get an answer energy of 34.87 into 10 raised to the minus 20 joules, because energy is measured in joules, isn't it? I've got this. Now I need to find the rate of emission. So this is the first part. Now for finding the rate of emission, let us erase this part and see. Rate of emission is found, let us write part B. Rate of emission, or you can also write as number of photons emitted per second, because that is what is rate, isn't it, comparing to time. So number of photons emitted per second. The formula is total energy of photon, which is given here, which already is given, 25 joules per second divided by energy of one photon. Okay, total energy of photon per second and energy of photon. Now simple, divide both, take the ratio. Here we have got, I don't have space, so I'll be doing it here. Here I have total energy equal to 25 joules per second here, divided by energy of photon. How much did we get? This is also in joules only, not a problem. It is 34.87 10 raised to the minus 20, right, joules. Fine. So when I divide this, I get an answer of 0.7169 into 10 raised to the 20 photons per second, because joules and joules get cancelled, it becomes photons per second. That is what they've asked. Calculate the rate of emission. So this is the rate of emission. So per second, how many a quanta of sin is emitted, energy is emitted, that is equal to 0.7169 10 raised to the 20 photons are emitted per second, it seems. So that is how you're going to do. Right. So let's see one more numerical. Here they are relating Bode's hydrogen atom, that's hydrogen spectrum. He has explained, he has given a clear explanation about hydrogen spectrum, isn't it? Right. So now we are going to relate the hydrogen atom as well as, let's see what is given actually. The electron energy, or the electron energy in a hydrogen atom is given by En is equal to minus 2.18 into 10 raised to the 18 divided by n square. That is the formula, right, according to Bode's hydrogen atom, hydrogen spectrum. Then what should I do? I need to calculate the energy required to remove an electron. I need to calculate capital E, that is important, or delta E rather, electron completely from n is equal to 2 orbit. Fine. Now the electron, what did it do? From the ground state, that is n is equal to 2, it has gone to the higher state, and from there it has come back to n is equal to 2. So I need to say calculate the energy required to remove an electron completely from n is equal to 2 orbit. That energy required to remove from that n is equal to 2. That is your Balmer series. Okay. What is the longest wavelength of light in centimeters? Fine. That can be used to cause the transition. That is what they asked us. Fine. So what should we do? Now, first of all, let me compare both. I don't have space, so I'll be doing one after the other. First of all, they said I need to calculate energy E. So for calculating the energy, let me write the given data. They've given me En is equal to minus 2.18 into 10 raised to the power of minus 18 divided by n square joules. This is what is given. Now for calculating the energy value, we have a formula, delta E is equal to, fine. So what is this delta E? Now they said it has gone from n is equal to 2. I need to take that energy to the infinity level, from higher minus lower. So E infinity minus En. Now what is n value here? It is nothing but 2. So this will be 2, isn't it? En value, okay, let me write instead of just to show E2 level. That is what I wanted to show. Now substitute in this formula, right? They've given me this formula. So delta E or En, both are same. So En. Now substitute E naught, E infinity. What is E infinity? Always taken as 0. Minus of minus 2.18 into 10 raised to the power of minus 18. And now n value is nothing but 2 square, that is joules. Now when I do this En value, I get an answer equal to 5.45 into 10 raised to the power of minus 19 joule per atom. So basically you can just write it as 0.545 also, not a problem. Right, this is your energy. Now what should I find out? I need to find the wavelength of light. Done. So let me take this out and then come back. So the second part of the numerical, I need to find the wavelength. So wavelength formula, I know E is equal to h nu. There is no wavelength here, but what do I know? I know nu is equal to c by lambda, correct? Yes, now substitute. E is equal to hc by lambda. Now what is h value? Now substitute all the values. But what do we require? I require this lambda, isn't it? Cross multiply this here, get that E down. Now what do I get? Lambda is equal to hc by E. En value I already got it here. Then I can directly substitute. What is Planck's constant? 6.626 into 10 raised to the power of minus 34 joule second. What is velocity of light? Equal to 3 into 10 raised to the power of 8 meters per second divided by energy, which I got here is 5.45 into 10 raised to the power of minus 19 joule per atom. Now when you cancel this, when you just solve this, you get an answer of lambda, which is equal to, there's the second box which I am drawing, which is equal to 3.647 into 10 raised to the power of minus 7 meters. So I think centimeters also you can write. Shift the decimal, you will be getting the answer in centimeters. Right, let's come back and see one more numerical based on your structure of atom. What do they give us here? Let's first write. So the mass of the electron is given to me, that already we know, isn't it? Right, anyhow, let us write the given data which is there. In the given data, mass of the electron is 9.1 into 10 raised to the power of minus 31 kg. If its kinetic energy is given to us, let us note that also. Kinetic energy is 3 into 10 raised to the power of minus 25 joules. What should I calculate? I need to calculate wavelength, that is, I need to calculate lambda. Second, they have given me 1 joule is equal to 1 kg meter square by second square. That is also over. Now first of all, what is the formula which is relating both energy and your kinetic energy in lambda? First of all, let's write kinetic energy formula and see. So kinetic energy is equal to half mv square. I know this formula. Then I need to find lambda. So suppose here this is given to me, this is given to me. If I find nu, right, the velocity of that, is there any formula which is related to lambda? Okay, there's one formula. What is that? Lambda is equal to h by mv, isn't it? We have learnt this earlier also. So let me start now. So kinetic energy, how much is this? Okay, I need to find what? Kinetic energy. Okay, I need to find v square, because this v I'll use it here. Take this v square out. What do you get? V square is equal to, now cross multiply, 2 into ke by m. V is equal to root 2 ke by m. Simple. Now substitute. V is equal to root 2 into, what is the kinetic energy? It is 3 into 10 raised to the power minus 25 joules, divided by mass of electron is 9.1 into 10 raised to the power minus 31 kg. But here what do they give us? 1 joule is equal to 1 kg into meter square. So instead of this, write the unit, because both should be in kgs. So you're going to write kg, meter square, second square. When I solve this, I get an answer of, how much do I get? I get, okay, square root and everything, 0. Basically, okay, what we'll do is, I'll first take, okay, anything will be the same, not a problem, 0.8119 into 10 raised to the power 3. Further, if I have to write, velocity will be 812 meter per second inverse. Okay, just I rounded it off. Now further I need to find lambda. What is lambda? Planck's constant is, this is the value of Planck's constant. Mass of the electron I know, that is 9.1 into 10 raised to the power minus 31 kg. Okay, there's no place here, so let me erase this part. I need the answer for this, isn't it? Right, into, what is the velocity which I got? 812 meter second inverse. Now when I calculate, I get an answer of lambda 0.008967 into 10 raised to the power minus 3 meter. Okay, this is the answer after calculating. One value is the velocity which I got from the formula. With that velocity I already know, because I need to calculate lambda, I have taken this formula and substituted. Right, so one more NCERT numerical. Let us read this. So nitrogen laser produces a radiation at a wavelength of 337.1 nanometer. Okay, right, so nanometer is given. Careful, you need to change it into the meter. Fine. So if the number of photons emitted is so much, they've given us the energy, the number of photon is given to us. Okay, calculate the power of this laser. Simple, there's nothing much in this. Let's write the data as usual. First of all, they've given me wavelength, that is 337.1 nanometer. Right, number of photons is given. Number of photons is equal to 5.6 into 10 raised to the power 24. Calculate the power of this laser. Simple numerical it is basically. Let's see. So whenever lambda is given to you, energy, photon, lambda and everything, this is the only formula which you can write. E is equal to h nu, basic formula. Right, nu we very well know, nu is equal to c by lambda, because lambda I need to use in this formula, so I'll write h c by lambda. That's also over. Now start substituting. Planck's constant value 6.626 into 10 raised to the power minus 34 joules second. Velocity of light value also I have written, divided by lambda value, it's in nanometer, because this is in meter, this is in joules per second, this also should be in meter. So you can convert it into 10 raised to the power 9 minus 9 meter. Now write that value, that is 337 into 10 raised to the power minus 9 meter. When I solve this whole thing, I get an answer, energy value, which is equal to 0.05896 into 10 raised to the power minus 17 joules. Further, you can also till now I've got energy. What should I find out? I need to calculate the power of this. Fine. That is energy of one photon. This is number of photons. Now let us write that. What is this? Energy of one photon. Now I am finding the part B, that is power. Energy of one photon. How much did we get just now? We've got 0.05896 into 10 raised to the power of minus 17 joules. Now number of photons. So energy of, let us write, energy of 5.6 into 10 raised to the power of 24 photons is how much? Right? So this into this, isn't it? So power is equal to 0.05896 into 10 raised to the power of minus 17 into 5.6 into 10 raised to the power of 24. Finally, I get an answer which I already noted, 0.3302 into 10 raised to the power of 7 joules. Energy, power or energy, same. I've got this. Further, if you want, you can shift the decimal. So you get an answer of 3.302. Okay, the same thing. When you are shifting the decimal here, this becomes 6, isn't it? So I've taught this in significant figure concept also, 6 joules. This is the answer.